I welcome you all to the lecture on process planning. Now, the topic today we are going to discuss is cutting speed, and myself Aravindan, I am going to handle this session. So, for the foremost process planning activities, cutting speed is one of the essential parameter or a process planning control parameter which needs to be properly optimized for a betterment of the machining process. So the cutting speed is not going to be common for all the machining operations. It will differ. For turning, boring, milling and drilling, the utilization of the tool is going to be entirely different. For example, speaking about the turning process, the usage is going to be your single point cutting tool. But whereas in your milling as well as in the case of drilling, the tool is going to be entirely different. So depending upon the tool variation, the cutting speed is also going to be variously calculated. Grinding is foremost completely entirely separate from this form of operations, right? So first of all, what is cutting speed? So cutting speed is nothing but it refers the speed at which the cutting edge of the tool passes over the surface of the workpiece. So again I am repeating, the cutting speed is referred as speed at which the cutting tool moves over the surface of the workpiece, right? So for calculating this cutting speed, this is a normalized formula. V is nothing but your cutting speed, where D is nothing but your diameter. So diameter of nothing, it is going to be the diameter of the workpiece. So if the diameter is going to be hollow, you are having internal as well as the external diameter, then you need to have a cumulative average of the diameter D. So followed by N is nothing but the RPM, revolution per minute, how much the workpiece is going to be rotated. So through this we are been calculating this cutting speed for this type of operations, where turning, boring, milling as well as the drilling. So in case of cutting speed, it is going to be mostly depending upon these following parameters. So if these parameters are going to be fine-tuned, the cutting speed is going to reach your optimal range. So such parameters are going to be tool material, right? From this image itself you can see that there is one cutting tool going to machining, or it is going to be turning some component, right? So from this image we can see over the workpiece and tool. So first we list that one as a tool material, second one work material, second one work material. Followed by this, you are going to have a relation of a tool and work material, the parameter, how much you are going to feed against the job. Depth of cut is nothing but the amount of material removed from the raw material in order to fine tune this into a finished good or finished job. So next one, tool geometry. So tool material, work material, followed by how much you are giving. So followed by the either it is going to be a single point cutting tool or it is going to be a multi-point cutting tool. So what is the tool geometry you are going to exhibiting? So finally a type of a machine tool. Then these are the output parameters which is going to be determined. Surface quality required. So these the first 5 types are going to be an internal one which you are going to decide. But the third layer is the one who is going to be your outcome. These are the inputs you are going to feed. So cutting speed is moreover depending upon both inputs as well as the outputs. So let me switch over to the planning as well as the shaping process, right? So how there the cutting speed is calculated, how, and it is going to be differ from the calculation which we have used for the drilling and the boring. So cutting speed for a shaping or a planning is defined as average speed of the tool during the cutting stroke and depends upon the number of strokes per minute with the length of the stroke. So cutting speed for the shaper and planner are going to be different in the case that the average speed of the tool during the cutting stroke followed by the number of strokes it's performed with the length of the stroke. Why we are speaking on the cutting stroke alone? Because during shaping and planning operation, the material removal will happen only on the forward stroke, which is termed as a cutting stroke. The return, during return, there is no form of cutting action takes place. For the quick enhancement of tool, we are having the with-work quick return mechanism. So before calculating this cutting speed, these are the basic terminologies we need to understand. So this is the way to calculate this. As I already insisted that L is length of the stroke and NS is nothing but your strokes per minute, number of strokes per minute. So the shaper is going to be move on the surface of the workpiece, during the cutting stroke. So how much strokes it is going to be performed inside this 60 seconds or a minute. So or the how much length it is going to be traveled during that particular time. So with this it will be calculated, followed by the cutting time ratio. What is meant by cutting time ratio? If my cutting time ratio is said to be 4:3, so total on 7 minutes, the 4 minutes have been utilized for the cutting operation and 3 minutes for my return operation. So my value is going to be 4 by 7. 4 by 7. For your easy and better understanding, let we have a cutting ratio of 5:10, right? Or 10:5 is better. 10:5. So 10 is going to be my cutting stroke and 5 is going to be my return stroke. So 10:5 is totally 15. Out of 15 minutes, 10 minutes is going for my cutting stroke. So when you cancel this, what will happen? So it is going to be 1:1.5, right? So its ratio is going to be function like that. So let me shoot out a problem on a planner. Let me read that into the question first of all. A planner. Now just you try to imaginary or visualize what is the concept I am trying to convey. A planner is capable of 15 strokes per minute at a length of 2 meters. A planner is capable of making 15 strokes per minute over a length of 2 meters. So the length of the stroke is going to be 2 meters, whereas within 15 minutes, within a minute, it can perform 15 strokes. The cutting time ratio for the machine is going to be 4:3. So they ask you to calculate the cutting speed. So this is the wide picture of the planner, right? My tool is going to be a stationary one and my work bed is going to be keeping on moving. The difference between the shaper and planner is the workpiece is going to be held moving on the planner because it can be useful during the long length components. But shaper, your workpiece is holded with a fixture at a fixed particle and your tool is going to be moved to and fro in a shaper. So this problem stipulated is a planner. Now what they are trying to convey for us, the length of this stroke. This length of this stroke is going to be 2 meters, and whereas within a minute it can perform 15 number of strokes. The cutting time ratio is going to be 4:3. So this is my solution for the problem. So these are my given data. So length equal to 2000 mm, stroke length equal to number of strokes per minute is going to be your 15. So how to calculate the cutting time ratio? It is going to be 4:3. So the total addition is 7. Out of the 7, 4 minutes has been utilized for the cutting stroke. So the total cumulative value is going to be 0.57. Out of 1, my cutting action will be 0.57. So this is the meaning for that ratio. So finally I am substituting inside the cutting speed formula L into NS by 1000 into C. So the result I have achieved for this type of cutting speed is going to be 52.63 meter per minute. So when I am operating at a 52.63 meter per minute, I am capable of performing 15 strokes per minute at a length of 2 meter, right? In order to have a machining of the workpiece in the ratio of 4:3. So this is the result we have incorporated in this problem. So with this, I hope you all been clarified or clear about the planar cutting ratio cutting speed calculation. Thank you. Let me meet on the next lecture with another topic.